Hey there, tech enthusiasts. Today we're diving into the world of DRAM, or dynamic random access memory. You know, that stuff in your computer that makes it go vroom. But what exactly is it, and why should you care? In simple terms, DRAM is your computer's short-term memory. It's like the sticky notes your computer uses to store information it needs to access quickly. When you open a program, your computer loads it into DRAM so it can access the data in a flash. Now, you might be thinking, why is this important? Well, my friends, DRAM is crucial for your computer's performance. The more DRAM you have, the more tasks your computer can handle simultaneously without slowing to a crawl. So, whether you're a hardcore gamer, a video editing wizard, or just someone who hates waiting for their computer to catch up, understanding DRAM is essential. Trust me, your computer will thank you for it. Now, DRAM isn't the only memory game in town. There's another contender called SRAM, or Static Random Access Memory. Both have their strengths and weaknesses, so let's break it down. DRAM, as we've discussed, is like the sticky note champion. It's fast and affordable, but it has one major drawback. It's forgetful. DRAM needs a constant refresh to retain data, kind of like how you need to rewrite a fading sticky note. SRAM, on the other hand, is like a permanent marker. It holds data as long as it has power, making it much faster and more reliable. However, it's also more expensive and takes up more space. So where do we find these memory types? DRAM is your go-to for your computer's main memory, while SRAM is typically used in smaller doses, like in your CPU's cache. Think of it this way. DRAM is the spacious but slightly leaky warehouse, while SRAM is the small but secure vault. They both play vital roles in keeping your computer running smoothly. All right, let's get our hands dirty and peek under the hood of DRAM. How does it actually store data? The answer lies in tiny electrical components called capacitors and transistors. Imagine a capacitor as a tiny bucket that can hold an electrical charge. A full bucket represents a 1-bit, while an empty bucket represents a 0-bit. Simple, right? But there's a catch. These buckets are leaky. Over time, they lose their charge, which is where transistors come in. Transistors act like tiny switches, controlling the flow of electricity to refresh the capacitors and prevent data loss. Millions, even billions, of these capacitor-transistor pairs form the building blocks of DRAM modules. Now, you might be wondering how your computer keeps track of all this data. That's where things get really interesting. Imagine a massive grid, like a giant spreadsheet, with each cell containing a single bit of data. That's essentially how DRAM is organized. This grid structure, also known as a matrix, allows for efficient data storage and retrieval. Each row in the grid has a unique address, and within each row, data is stored in individual cells. To access a specific piece of data, the DRAM controller sends signals to activate the correct row and column. To speed things up, DRAM uses something called sense amplifiers. These amplifiers are like tiny signal boosters, amplifying the weak signals from the capacitors and making it easier for the controller to read the data. This intricate system of rows, columns, and amplifiers allows your computer to access data stored in DRAM with incredible speed, enabling it to handle complex tasks and run multiple programs simultaneously.